In C1 you're asked to be able to use and manipulate surds. In order to do this you really have to be able to simplify them. Usually there are two rules I ask boys to follow. First of all, simplifying surds is very much like simplifying algebra. And secondly, always look out and see if you can simplify surds using square numbers. I'll show you what I mean. Root 12 can be written as root 4 times root 3. And root 27 can be written as root 9 times root 3. 4 and 9 are square numbers, so we can actually simplify these to 2 root 3 plus 3 root 3. And just like algebra, because the surds are the same number or base underneath the square root sign, we can add them to get 5 root 3. Taking the next example, root 50 we can write as root 25 times root 2, and root 8 we can write as root 4 times root 2. Really we're looking to simplify so that both the surds have a surd with the same base like we have here. Now root 25 becomes 5 times root 2 minus 2 root 2, and this simplifies to 3 root 2. In the final example we're going to again try and simplify to give us root 2's. The first term is going to be 2 times root 4 times root 2 plus the second term, which is root 36 times root 2, minus the third term, which we already know from above is root 25 times root 2. Now simplifying each of these, root 4 is 2, so the first term becomes 4 root 2 plus 6 root 2 minus 5 root 2. And because each surd has the same base number, we can simplify this easily to 5 root 2. You should now try the 6 questions on page 17 of the notes booklet.
That comes from this year or something like that? Just something.
If we're asked to multiply surds, we simply carry out the multiplication almost ignoring the surd that we have. For example, root 5 multiplied by root 3 will be the square root of 15. But it also works in reverse. If we have the square root of 24, we can simplify that by splitting it up into two numbers that multiply to give us the square root of 24. For example, the square root of 8 multiplied by the square root of 3. However, we could also have split it up into the square root of 12 times the square root of 2, or indeed the square root of 4 multiplied by the square root of 6. But probably the best option is to always take the terms of which we've got a square number. This will simplify the easiest. Let's look at some examples. Root 5 times root 15 will give us the square root of 75. However, in the question we're asked to simplify this, and the square root of 75 can be simplified further to the square root of 25 times the square root of 3. We used the square root of 25 because we knew of it as a square number, and that will hence simplify to 5 root 3. In the next example we have a bracket multiplied by 5, so multiplying each term by 5 we get 5 plus 5 root 7, and we have to leave it like that. In the final example we have two brackets, so multiplying that out, the first term is 35, then 5 times plus root 3, then minus root 3 times 7, and minus root 3 times plus root 3 is minus 3. Simplifying further, just taking the numbers without surds, we have 35 minus 3 is 32, and 5 root 3 minus 7 root 3 is minus 2 root 3. If we're dividing surds, we follow another simple rule. If we've got a fraction such as 9 over 2 and we're taking the square root of it, we can rewrite that as the square root of 9 divided by the square root of 2. But in this case, of course, the square root of 9 is 3, so we would simplify it further to 3 over root 2. Or, taking it the other way around, in reverse, we could have the square root of 8 divided by the square root of 2. But we could write that as the square root of 8 over 2. But we know 8 over 2 is 4, which would give us the square root of 4, which indeed simplifies to 2. Looking at some further examples, in example B, first of all we should be simplifying root 32. So that could be written as the square root of 16 times square root of 2. Again, looking for square numbers. The square root of 16 is 4, so it becomes 4 root 2 over 2, but indeed that will simplify to 2 root 2. In the second example, we've got a mixed number and we're taking the square root of it. So the simplest thing to do here is first of all write it as a top-heavy fraction or an improper fraction. And we can now use our rule for dividing surds to in effect split this up to the square root of 9 divided by the square root of 4, both of which are square numbers, and the answer will just become 3 over 2. In the final example, we again can use our rule for dividing surds and split that up to the square root of 75 divided by the square root of 9. Now, again, looking for square numbers, root 75 can be written as the square root of 25 times the square root of 3. And we know that the square root of 9 is just 3. Square root of 25 will simplify to 5, so we end up with 5 root 3 all over 3.